Unit 11, Lesson 3, Inverse Trig. At the end of this, you'll be able to determine the measure of a special angle given the value of a trig function without a calculator for the special unit circle angles using inverse trig functions. You'll also be able to do inverse trig on calculator for those items that are not some of our special unit circle angles. And you'll also be able to define the range for the inverse trig functions of cosine, sine, and tangent. Now, first, let's review. Trig functions find the ratio of two linear measurements or sides of a triangle based on a given angle. Remember that we have our trig function. We pass it the angle, and it returns the ratio of sides. Looking at sine, sine of theta, where theta is the measure of our angle, returns the measure of the opposite side over the hypotenuse. The cosine of an angle returns the adjacent over the hypotenuse, and the tangent of an angle returns the length of the opposite side over the adjacent side. Now, when solving an inverse trig function, you are finding the measure of an angle. Trig functions, you find a ratio of sides. Inverse, you find the measure of an angle. The inverse trig functions undo what the trig functions do. So trig function angle equals ratio of sides means that inverse trig function ratio of sides gives you an angle. Now, you can have arc sine or sine raised to the -1. These are synonymous. They mean the same thing. Arc sine is red, the angle whose sine is. Now, just so that you can see it a little clearer, the inverse trig function takes the ratio of sides and gives you the angle. So the inverse sine takes the opposite of the hypotenuse and gives you back theta. Cosine, inverse, takes the adjacent over the hypotenuse and gives you back the angle. The inverse tangent takes the opposite over the adjacent ratio and returns the angle. Now, functions have how many outputs per input? Remember, 1. You have 1 output per input. Okay? Now, if you think about this one, what angles have a sine of 1/2? Sorry, sine theta is equal to 1/2. Well, if I take and I look at this, here I've got the sine would be 1/2, so that's pi over 6. And I keep running around the circle, and oh, look, here's another one where the sine is 1/2, and that's 5 pi over 6. Huh. And if I keep going around, I have -1/2, -1/2. I don't have any other halves. But I have pi over 6 and 5 pi over 6. So how in the world can the inverse sine of 1/2 be a function? Here's how. We restrict the range. We don't allow us to be in this section. Notice that over here, if you want to take a look, give me my pen, so root 3 over 2, root 3 over 2, root 2 over 2, root 2 over 2, 1/2, 1/2, 0, 0, -1/2, -1/2, negative root 2 over negative root 2, negative root 3 over 2, negative root 3 over 2. What we're going to do is we're going to ignore essentially this half of the unit circle and only go from here to here. But instead of going from 3 pi over 2, we're going to make this negative pi over 2. We're going to go from negative pi over 2 to pi over 2. And this is the range that will be restricted. Now, for each inverse trig function, the range is restricted so that only one angle is given for any particular ratio. This is the answer to the inverse trig function. The inverse trig relation might have multiple, you can still give multiple answers, but you as the human have to determine if those answers make sense. Okay? So it is up to a person to interpret what the other angles could be and if they would be solutions as well. The calculator will also only return one output angle for any given input ratio, and it's set to be the function. How are these ranges restricted? Well, I just showed you on the sine, but let's look at it again. We go from negative pi over 2 up to pi over 2. Right, so we go all the way this way. And the reason is, again, these over here repeat. Now, why is it negative pi over 2 and not 3 pi over 2? Well, because what we want is we want a continuous flow for our function. So therefore, here. So here, I want to look, oops, okay, we'll do this and I'll move it over. We want to look at just this section. This is a continuous section. If we did 3 pi over 2, okay, remember that 3 pi over 2 would be from here to here, which is the same y values as this, but then I would have from 0 to pi over 2 is here. So it would be a discontinuous function. We want a continuous function, thus going from negative pi over 2 to pi over 2. So answer the following. From 0 is less than or equal to theta is less than 2 pi. What is the inverse sine of root 2 over 2? Well, you can cruise along here. These are all your negatives. These are all your positives. And notice here's your root 2 over 2. So your answer is just pi over 4. Are there other angles? Certainly. But this is the answer to the inverse trig function. The inverse sine of 0 is 0. Okay, it's right here, and I can read it off the graph. Now, the inverse sine of negative 0.2384. Ooh, that I'm going to have to use a calculator because it's not one of my special angles or special values. So I pull up my calculator, turn it on, and I clear it. And I want to make sure I'm in radians because this is radians. So I'm going to go to mode, and I'm going to come down here to radians, make sure that it's in radians. And then here, see sine inverse? I'm going to do second sine, and then I'll put in negative 0.2384. Now my answer should be negative because all my negative angles are down here. I press enter, and I get negative 0.2407. That would be all I would write here. Radians. It's not degrees, it's radians. Okay? Now, let's look at inverse cosine. So on for cosine, the inverse cosine theta. Just like the trig functions, the inverse trig functions involving our special angles must be done without a calculator. Now for cosine, we're going to go from 0 to pi. And why 0 to pi? Let me do this. Yeah. Do it with a little bit. Okay. We're going to go from 0 to pi because if you look over this part, I've got positive values, and then I've got those same, whoops, and then I've got those same values as negative. I'm looking at the x values, right? Down here, they repeat. So I'm not going to pay attention to these for trig functions. The inverse cosine of negative root 2 over 2, that's going to be 3 pi over 4. Does it also equal 5 pi over 4? Of course it does, but not as a function. Now, if I want it in degrees, well, then 3 pi over 4, I have to remember, is 135 degrees. I'm really going to ask you just in radians. The cosine of 3 pi over 2, well, that's pi over 6, or 30 degrees. Now, if I ask you for the inverse cosine of either one of these, and I want it in degrees, what you're going to have to do is, again, go to the mode, come down, change it to degrees, and then you're going to quit out of this, you're going to do the inverse cosine of 0.8431, and you hit enter, and that's 32.53 degrees. 32.53 degrees. Notice it's positive because it's a first quadrant angle. Where'd it go? If I go to second cosine of negative 0.3344, I'm going to get 109.53. And I'm going to do, this one I'm going to make 33 degrees, and this one I'm going to say is 110 degrees. Round it to the nearest degree. Now, the one thing, I'm going to go back and do the sine in just a second. My question here says from 0 to 360. So what I have to do, I'm going to erase those, I have to take into consideration this is only the one angle at 135. Where else? I have to be the human. Where else? Is it negative root 2 over 2? Well, that would be down here at 225 degrees. That's the other one. This is the answer to the question of the function. This is the second angle that I would give. 30 degrees, I also have 330 degrees. Again, answer to the function, answer within the whole unit circle, or the whole circle. 33, well, how do I find where else? Well, since it's positive, I know I'm in the first quadrant or the fourth quadrant. So I'm going to do 360 minus 33, and that's going to give me, I can do this, 327 degrees. 110 degrees is here in the second quadrant. Cosine is negative in quadrants 2 and quadrant 4. So if I'm at 110 degrees here, how do I find quadrant 3? Well, I know that I can find my quadrant 1 angle, and that's going to be my reference angle. So 180 minus 110 is going to give me 70 degrees. This is my reference angle. Now I want to go in the third quadrant. So this is going to be 180 plus 70, which will be 250 degrees, and this is the second angle. Again, I'm looking for an angle in my trig function. The inverse trig function will give me quadrant 1. The other place where cosine is positive is quadrant 4. Is quadrant 4. Then down here, it's negative, so I'm going to get a quadrant 2 angle. The other place that I need to look at is quadrant 3. If I back it back up here, just so we can say, from 0 to 2 pi, the sine is root 2 over 2. Where else is sine positive? Well, it's positive in quadrants 1 and quadrant 2. So this would be 3 pi over 4. 0, well, it's here. Where else is sine 0? At pi. Now don't put down 2 pi because notice this is less than 2 pi. Down here, I forget what we got. We got negative 2.2 something. That's going to be this is going to be, give me a negative fourth quadrant angle. So all I'm going to do is take and do 2 pi minus that amount, okay? Or 2 pi, sorry, 0 minus that amount gives me the negative angle. I want to be all the way around, so it's going to be 2 pi and then minus or plus that negative amount. Got a couple more later that I'm going to show you. Tangent Tangent is the same thing. We're still going to go from negative pi over 2. Oops, it's a correct one, up to pi over 2. And that's because, notice here, negative pi over 2 to pi over 2, and your asymptotes occur on the pi over 2's. So, it has the same restricted range. The inverse tangent of 0.7335. It all depends on whether or not I want degrees or radians. So if I look at my mode, it's in degrees. I really don't care right now. Actually, let's change it to radians because that's the one that you're going to be asked more. Second tangent will give you the inverse tangent. This is going to be 0.7335, and I press enter. And tangent is positive in quadrants 1 and 3. So what would I do? Well, I would take 0.6329, 6,3,2,9. I know it's giving me a first quadrant angle, so to get the third quadrant angle, okay, so this is my quadrant 1. To get quadrant 3, I would do pi plus that. So 3.14159, so make that a 6. And there's my third quadrant angle. Okay? Tangent is 0. Well, that's at 0 and at pi. For these guys, for this one, I would plug it into the calculator. And again, you get crazy stuff. If you look at negative root 3, okay, that's going to be down here. That's going to be at 11 pi over 6, or negative pi over 6. And if I want it going all the way around, that means I'm going to have 5 pi over 6 and 11 pi over 6. So notice this is the answer to the function, but from 0 less than or equal to theta less than 2 pi, these are the answers. Right, so here's some no calculator practice. What you want to do is pause the video and try each one of these. Now notice this is inverse trig function. Okay, so that means I only want one answer. I don't want from 0 to 2 pi, I just want one answer. So pause the video and try these, and then start the video to see if you're right. Okay, you're back. Now remember, for each one of these, you want to know what angle has a tangent of 1? Pi over 4. And let's see if I can do this. Copy. And I'm only doing this so we've got a reference. Paste. I'm going to go really tiny here. I'm going to erase this. Erase all that up there. And then we're going to go. Okay. So that way you can kind of have this as your reference up in this corner. Okay, so the tangent is pi over 4. The inverse cosine of 1. Where is cosine 1? Right here at 0. The sine of the inverse sine of 0.8. Oh, remember when you compose a function with its inverse, you get what you started with. So even though 0.8 isn't one of my unit circle things, I can still do it. It doesn't matter if I do inverse sine of 0.8 or the other. Where is cosine? When you see inverse trig function, think, where is the, in this case, cosine 0? Where is cosine 0? Oh, right here, pi over 2. The cosine of the inverse sine of 4/7. Well, 4/7 is not on my unit circle, but I can draw a triangle, and I can say sine is opposite over hypotenuse. So I can do Pythagorean theorem, 4 squared plus something squared is equal to 7, and find out that that's root 33. Then I can do the cosine of this triangle is the adjacent over the hypotenuse is root 33 over 7. Inverse, so notice here I never had to know what the angle was. I could just drop a triangle. Inverse sine of 1, well, where is sine 1? That would be at pi over 2. Where is cosine 0? That's at pi over 2. Where is sine negative 1? That's down here. Now be careful, remember that I'm not going to do the 3 pi over 2. This is negative pi over 2 down here. Okay? Got to be careful there. So it's at negative pi over 2. The sine of the inverse tangent of negative 1. Work from the inside out. Where is tangent negative 1? Where is tangent negative 1? That's going to be at negative pi over 4. Then at negative pi over 4, what is the sine? Negative root 2 over 2. Okay, so if you're doing this, this would then become the sine of negative pi over 4. The sine of the inverse tangent of 3/5. Again, 3/5, not on my unit circle, but I can create a triangle. Opposite over adjacent, opposite over adjacent. Use my knowledge of Pythagorean theorem and do 9 plus 25, and then take the square root. You get the square root of 34. Then the sine is opposite over hypotenuse, so it's 3 over root 34, but then I have to rationalize. Same thing here. I create my triangle, and I simply do, in this case, cosine opposite over hypotenuse. This last one, where is the tangent equal to 1? That's at pi over 4. Remember, tangent is y over x, root 2 over 2 over 2. So that's going to be at pi over 4. Here are a couple of 2 steps. Let me bring this guy all the way down here just so that we can kind of see him. Okay. The inverse sine of 1/2 plus the inverse tangent of 1. Where is sine 1/2? Pi over 6. Oops. And then where's tangent 1? Pi over 4. Make like denominators, and the answer is 5 pi over 12. The sine of the inverse sine of 1 plus the inverse cosine of 1. Where is sine 1? At 0. Oh, sorry. Sine is 1 at pi over 2. Cosine is 1 at 0. So sine of pi over 2 plus 0 becomes the sine of pi over 2, which is just 1. Got it? You've got to be able to go back and forth, in and around. In summary, the inverse trig functions return the angle measure given a ratio of sides. The inverse trig functions on the calculator have a restricted domain when finding angles 0 through 360 or 2 pi radians. You must use the returned angle to calculate any of the other requested angles. So you've got to look, do you want just the answer to the function, or do you want from 0 to 2 pi or 0 to 360? Inverse trig functions can be denoted using a superscript of -1 or the letters ARC preceding the trig function. The restricted range for each inverse trig function is as follows. That's it.